Hey, what is up, everybody? It's Ivan here, and in this video we'll actually finally will be running the Tiny Yellow on our Android devices. We've come like 5 videos to get to this one, and we're gonna be building a lot in the foundation of the previous video. But in this video we'll actually get it to run on our devices locally, and be able to then post-process the output. And here you'll probably see the demo of what's going on there while I'm talking. So like guys, it's taken quite some time to get there, but I hope that now that we're here at this tutorial, I hope that you guys are excited. And before we start, please consider subscribing, because it's the series and there are gonna be like new videos on how to analyze faces, do face detection, and then how to read multi-digit numbers in Android, and hopefully some more cool stuff with it coming. So yeah, why don't we get started? And by the way, like the code will be on GitHub, and if you'd like to support me in any way, shape or form, some ways that are in the description. So smash that like button and subscribe. And yeah, I'm making this little pre-roll after we've already made the code some a little bit, getting. I don't know how to say it, but it gets hard to say the words. But anyway, let's get started. Okay, so as was promised, now we'll in the first part we did the heavy lifting with getting all the weights and stuff to work on Android. But right now we're actually gonna who needs a neural net if they can't get the data from it, right? And now we'll actually in this video figure out how to actually post-process the outputs of our Tiny Yellow. And well, how do we do that, you may ask me? First of all, let me show you something. So I just went ahead and opened up the CV2, the DNNs folder with our Tiny Yellow and Tiny Yellow weights inside of PyCharm to show you something. So for instance, if we'll go ahead and we'll say that net, and I'm just gonna show you something. So we gotta to extract the outputs, we actually gotta specify the layers from which we want to receive the outputs. And first of all, if we look at the CFG file of YOLO, the Tiny Yellow have 2 YOLO layers, and YOLO layers are actually layers that we're interested in, and because that's where all the predictions are. And the reason it has 2 of them is so that it could predict on the different scales, so that it could do better with smaller objects as well as bigger objects. And the big YOLO, which the one with which weights are 20 to 200 megabytes, it's got 3 YOLO layers. So those guys are important. They have the outputs, and we want to be able to process each and every one of them. So we'll say here CV2 DNN readnet from darknet, and we'll by the way, this is gonna be an informative tutorial. So if you never had any experience with this stuff, I'm gonna walk you through all the stuff so that then, and it's important, because so that then when you actually use your neural net that you've built or that you found by browsing the endless horizons of the internet, you'd be able to basically replicate all the steps. That's important, because whenever you're gonna be trying to work with the net that you haven't worked before, you don't know the specifics of, you're gonna be wanting to check it out in Python. So that's actually pretty freaking important. So YOLO with version 3 tiny.cfg, so we'll just load in this guy inside of Python, and tiny wait. So now let's say print get layers, I think it's. So okay, I went ahead and copied the get output names function from the first video, and now let's run a few commands here. So if we say here get layer names, first let's see what that will give us. Now it'll give us all the layers, and we're looking for this YOLO layers, YOLO 23, and which is basically their order, and YOLO 16. So for instance, if after that we'll run we'll run net.get unconnected out layers. And unconnected out layers is, is probably like in most of the cases, unless it's like, some recurrent net or something, like the unconnected layers are the layers where the prediction is happening because they no longer forward their results somewhere else, and like they can, it's like the endings of the network where like all the magic is happening, except YOLO has obviously like 2 of them, and the big one has like 3 of them. So we'll run this guy here, we'll see this. So these indices here are 36 stands for, I'm not gonna count this whole thing, but basically this index here is 48 and this index here is 16. So if we were to be like, hey, show us the 48th element here, it would basically, why not, okay, 47, yeah. So it'll show us, for instance, the last YOLO layer. So that's what this function does. But here, what we kind of want from it. So if we'll go ahead again and we'll run get output names, like this function here, like write it down your hand or tattoo it on your back and mirror it and then tattoo it on your back and put the mirror beside you, and you'll be able to like basically flip your head and read it from your back. Yeah, I'm going a bit crazy with all this code. Anyways, so we'll get the output layers of that network. We'll find these 2 guys, and the reason why that's important is that we're gonna specify it in Java, and in Java it's the whole lot different to specify than in Python. So that's kind of like the shortcut that you can use to find the output names of the layers with OpenCV of your neural net. So now let's go and implement that in Java. Okay, now let's actually get our hands dirty. So, this end input part is the same, give it the blob. We've learned, what the blob is. It's the four-dimensional matrix input to the convolutional neural networks. And, what are all those values there? Like, watch the previous video if you want to learn about that. Yeah. So, here's why those, your layers are important. So, here's how it works. So, we know that we want 2 matrices as the output. So first we define the result. First we define the result list of maths, which is like the Java syntax and all that, and they'll be filled with 2 YOLO layers. And out blob names is basically the names of those. So we create this out blob names list, and then we fill it up with 2 values: the value of the first tiny YOLO layer and the value of the second YOLO layer. And here's the important part: if you want to run the big YOLO, all you have to do is to just change this. Just add the 3rd guy here and add another guy here with all the 3 big YOLO layers, and like the code that I'll show you below will basically work for the big YOLO as well. So let's go. Anyway, so we define the layers that we're looking for, and we define where to put them. So right now let's learn how to actually post-process the output. Okay guys, so here I have copied the code that some parts of it I found on the internet, some parts I've modified. So yeah, this is the code that post-processes the outputs and then puts text in the rectangles. That's the text that draws all the good stuff then on our phone screen. So let's kind of look at it. Yeah, let's do that. So first of all, we define here Now these parameters I fine-tuned myself to work for 10 YOLO, so they should be good, but here's where we define the confidence threshold. So if you have like your custom model and you wanna, you know, have it like a lesser confidence threshold, that you can specify that here. Then we have 3 lists, and a list of integers, which is the list of class IDs that the model will find. You know, there are like 80 classes in YOLO and, you know, stuff. Just hope you know that. If you don't, watch the YOLO version 3 series, now learn how to train your own. Anyway, then we have the list of confidences that will be, you know, comparing like which ones are bigger than threshold, and the list of rectangles. And rects or rectangles are they're like OpenCV's, like it's OpenCV in Java, so it's got like a lot of nice functions here. And rectangle functions like an object where you can access the x1, y1, y2, you know, where you can basically access all the coordinates of the bounding boxes, which is awesome if you want to like draw the rectangles around them. So, first of all, we go and we iterate over the size of the result list, and as you remember, that's why it's gonna be, you know, flexible for the big YOLO and for the tiny YOLO. If in the case of tiny YOLO, the size of the result guy will be 2, so iterate over the 2 YOLO layers. If it's the big one, it'll iterate 3 times. And here, max level result get. Okay, so and we get like the level. So level is basically like in each case it's gonna be the YOLO layer. So then we go and we so we iterate over each of its rows, and then we access a row. So we, you know, we can see like we iterate over how many rows it's got. And we access a row, then, and by the way, like I'm gonna walk you through like each line here, but if you come from Python, like that's the kind of weird part, because in NumPy everything is like nice and intuitive, and here it more feels like, you know, you can do everything, but it's not as intuitive. Instead, you've just got a ton of functions that can, you know, do a ton of useful things for you, but it's less intuitive, but there are like more functions that can do things. So, but once you can wrap your head around how this code works, like on the top level, you'll be able to post-process your own network's output, and that's kind of what the purpose here and stuff. So here you can see some funny syntax. We define the core from OpenCV, min-max-log results as like the type of the object. And here we say like min-max-log scores. So we define its own object to find the maximum score here, and then the confidence will be the maximum value of that guy. You know, right? How when YOLO picks its class, it's got like its coordinates, and then it's got like 80 like 80 neurons here, right? Like it's got like 80 neurons, and those are like individual neurons, so it's like 0, 1, 2, 3, 4, and like up to 80, or I guess like in this case it's 7. Yeah, now that's right. Okay, and basically we're going to like those rows, and whichever neuron is of those 80, like for instance the first neuron is a person, and the 80s I don't remember what, but the second I think is a car, and third is a bus, something like this, and like 80s maybe like a toothbrush, and the 45th may be a chair, right? So for instance, if like the first neuron has the maximum value, it's a person, right? So here it'll basically be like, you know, the maximum value. So like the maximum value is on the first neuron, let's say. So for instance, it's like 0.5, so it's 50% confident that it's a person, and it's like the maximum value. And for each of 7 of those rows, it can only predict like one guy. So, you know, there cannot be this guy 0.5 and this guy say 0.4. They're both above the 0.3 threshold. Like it's not gonna work like this. Like for each guy, like for each row, there's just one prediction to be made. So it'll find its maximum value and the maximum location, and the maximum value will be the confidence, and the class ID point will be its maximum location. Whew. So here we'll check if the guy's confidence is bigger than its threshold, and if it's bigger than the threshold, then we'll process it and add our classes to the ID, and out add to that integer list, to the float list we'll add the confidences, and to the rectangles we'll add the coordinates here. And then we'll do that, then we could perform the non-maximum suppression, which we'll get in a moment. So the way YOLO predicts the outputs, like first of all, it predicts them in percentage values, which means that, like it's all in percentages, right? So if YOLO finds an object in the in like the center of the screen, it's gonna be like 0.5x, 0.5y, and then it also predicts its width and height also in percentages. So first of all, we extract all those values and we convert them from percentages to pixels. How do we do that? So first of all, we get the center x value here from that row, and we multiply it by the by the width of the image. We multiply the thing is, we have like 1, 2, 3, 4, right? Gosh, shit. Anyway, yeah. So then we multiply its center y by the height of the image, by the amount of like rows it's got, which is gets us the pixel value, and convert that to integer. And the same thing with like width and height, convert that to pixels. And then we can calculate the the left the top left point. Yeah, we can calculate basically the leftest point and the topest point. And then using all those guys, we can then construct a rect object. And the beauty of this rect object is we can, it's a rect object, and we can easily, let's say, get its x values or its height or its or even if it's like top left area or its bottom right area. Now, don't no worries if it's not super clear. Just pause the video and it's pretty straightforward here. I hope. In each row we just get the each row when we just get like zeroth guy, it's first guy, it's second guy, it's third guy, and convert them to the rect object. So now when we've done that, we get the array length, which is how many of those neurons were good, like how many of those rows that it went through over the 2 YOLO layers, because it's also like happens for 2 YOLO layers, and of those rows that it went through, like how many like good stuff have it found, right? And array length is basically the size of confidences, or the size. It could also be like the size of class IDs, but whatever. And then we see if array length is more than 1. So if it's more than 1, we can apply a non-maximum suppression. What is non-maximum suppression? What may happen if you have like a cell phone, right? YOLO may think that like this whole thing, like it can draw like, okay, it can draw like this bounding box over this cell phone, but it can also draw like the bounding box, a bit lower, and then suddenly you have not just one cell phone, you've got like 2 cell phones. And to avoid that, we apply the non-maximum suppression. Basically chooses, I think, it looks at which boxes overlap, and then it picks the one with highest confidence, with this threshold. I think that's how it works pretty much. We just apply the non-maximum threshold. I've chosen it through like trial and error, so it should be good for tiny YOLO. So in here we give it the Matterfloat Here goes again, like some weird syntax here. Convert it to like, so convert vector flow. Okay, yeah, convert the vector float to matrix, so we convert conferences to a matrix of floats. Then we get all of our rectangles and stuff. Gosh, I have to look at this code again. So here we basically pre-process for the non-maximum suppression the boxes, like the rectangles, the conferences that we've got here. We give it the confidence threshold and the non-maximum suppression threshold as well, and we'll also give it a list of indices that it will basically fill them up, you know, with the boxes that basically that the non-maximum suppression worked on. So then once we've got those indices, we can go and start drawing them. So here, as you can see, I've already got some code that'll, you know, it'll iterate over. So okay, here's what's going on here. So indices is actually like a list array guy of indices of this three list here. These three lists here of classes, convs, and rects that are correct according, that are good according to non-maximum suppression. So what does that mean is that when converting indices to like array, iterate over them, we take the actual good, like it's a list of good indices for these three lists. So we get the good index for like the boxes array, like the good index for all those three lists, and then we give that good index to boxes and to classes. We want to take that. We can also get here, say, confidence, so it'll be something like float conf, and it'll be like confs that get and idx. And yeah, and here I have some code that basically that basically displays all the outputs. So for instance, here it'll put text in the top left corner of the box, and yeah, we just gotta do one more thing. So okay, now what's left is to just pre-process. Like this is like the beautiful and the fun part, where we just draw the rectangles and hang out with unicorns and drink some morning dew. You know, that's what we're kind of doing here. So I went ahead and like also copied the list of Coco names, which is like, wait, something is not something that right here. Okay, so here's like the list of all the Coco names, and here we can actually like process the output. So we'll say that before putting text, we'll say that integer confidence will equal like name it like infconf will be confidence converted to int confidence times 100. Okay, and id guy is the id of this guy here, so that'll be Coco names get id guy, which will give us the name of the class, and then we'll display some space here, and let's say we'll put our integer confidence here, and then yeah, we'll put our integer confidence in, and some percentage sign. Yeah. Yeah, that should work. Then we'll also give it our box top left, thingy, the coordinate. We wanna put the writing in the top left corner. If it's like a phone, you wanna place it like here or here. And font and colors, it's all pretty basic. And also draw the box. We give it the top left coordinates, the bottom right coordinates, the color, which is that nice blue color that I think I've had in the demos. Let's change it to it's RGB now, because the image is in RGB. Remember it's. So let's have them be red, and the color of the writing, it's white now, and let's have it be whatever the color. It's RGB. Yet let's have it be blue, maybe, or let's have it be green. Actually, I like green color. I'm wearing a somewhat greenish shirt today, so yep, that should do it. Alright, that should do it. Haha. Do you think that'll do it? I hope it will. So let's check it out right now. I hope that you followed all the previous parts and already have all the stuff set up. And by the way, like, code will be on GitHub, so no worries if it's a little bit crazy at first. Okay, so we actually got it to freaking work. How cool is that? How cool are we? So, you've probably already seen the demo in the beginning because I'm gonna record it right now, but here's some proof that it's actually working. See, a cup. By the way, the confidence is 0%, so it's kind of not convincing. So, Wait a minute, we may have not actually got it yet. Okay, so I found the bug with confidence. So here you can see we first convert the confidence to the integer, and then we multiply it by 100. So it's like always goes to 0. Here's how we can fix it. Just a couple of little brackets, and let me build the app again, and let's see how it goes then. Oh, and just one quick thing, I've also added some lines of code here that will, they'll basically, if you turn off the display and then you turn it back on, sometimes it, throws some stuff out of memory, so now we'll check if start YOLO is currently true, which is like if it's supposed to be showing YOLO, it'll launch it again. If you like turn on and off your display, it'll just prevent crashes, and it's again super straightforward, and we'll do it like on GitHub. So yeah, just back to the video. So yeah, I think we got this. So I fixed the bug with like confidence and stuff. So now go to our app and click on like show. Now it's in yellow, so it's not great with detecting people up close, but for instance it can detect a cup if it wants to, of course. So you can see like a cup, right? I mean, you've probably already seen the demo in the beginning. I'm still playing with the like what colors look best for this guy, but for like this thumbnail and stuff, if you know what I'm talking about. But anyway, yeah, a cup. I can also like show you, well, my old computer mouse. So like it's tiny yellow, so it's not going to be like extraordinary, but it can, detect a few things. Computer mouse, book. So it's working. Like if you want to run the big yellow, you can totally do that. Just change the names of the layers, and that should be magic. And but however, just beware that on my phone pressing the big yellow takes about 15 seconds, so it's more than 2 seconds, kinda. And yeah, so I guess that's it. I'm also gonna be releasing how to do face detection, how to read numbers, and maybe some other upload to Play Store stuff, hopefully. But I think that's it for this video, guys. Thank you so much for watching this video. Thank you so much for your comment. Definitely leave your comments and questions and suggestions, and also let me know what kind of app are you building. Also, if you are in a position, if you want to, that would be really cool if you support me. If you again in a position and you want to, and you feel like it's a good thing to do, ways to support me are in the description. Also, smash that like button to let me know that you're just as excited for the series as I am, and also subscribe so that you wouldn't miss the next awesome tutorials and podcasts and whatever you like. Also, yeah, thank you so much for watching. I wish you are having a great day. Bye.